Okay, so for geometry, we focus just on right triangles and applying the trig to the right triangles. You can use trig with non-right triangles, but it gets more complicated. So always going to be right triangles. So a little review: sine A, cosine of A, tangent of A. So remember, I'm looking at angle A, and if I want to find the sine, so remember I said I would always write this acronym on your papers from now on when you're working on this stuff. So sine is going to be the opposite side over the hypotenuse. So remember, if we're looking at angle A, opposite would be this side. Hypotenuse, remember, across from the right angle. And I always identify, again, the adjacent last. So sine is going to be 1 over square root of 2. And if you remember, we would want to multiply that by square root of 2 over 2. And remember, this equals square root of 4, which is just 2. I'm going to do that on the calculator then. Okay. And then cosine would also be 1 over square root of 2. So I'm just going to skip to the fact that that's actually equal to square root of 2 over 2, which equals 0.707. Tangent, it's just 1. Okay, so what type of triangle is this? This would be it's isosceles, right? Because it has two sides that are equal. And what could we say about these angles here? What should they measure? They should measure 45 degrees. And remember now, no matter how big, now that we know that this is a 45, 45, 90 triangle, I could make this triangle bigger and these ratios would still be the same. So let's look. What do you think the sine of 45 is going to equal? Equals 0.707. What do you think the cosine 45 is going to equal? And I'm guessing you can probably guess what the tangent of 45 is going to equal. Kind of just already said the answer. So what this means is if we know an angle of a right triangle, then I know what these ratios are without actually even seeing the triangle. So if I knew angle A was, let's say, 55 degrees, I could know the ratio of the opposite side over the hypotenuse without seeing the picture. It's going to be the same for any right triangle with a 55-degree angle or any right triangle with a 60-degree angle. Those ratios are always going to be the same. This is why trig is so useful. This is why we can use it to solve problems. So let's look at some problems then, trying to be a little more on top of things with the pictures drawn already. So I can find a side of a triangle, a right triangle, if I know one angle and one other side. I can figure out this side. So one thing that's going to be important is we're going to want to label the sides with respect to the angle we're given. And by labeling the sides, I'm talking about labeling the opposite side, the adjacent side, and the hypotenuse. And like I said, if you can do those, if you can label those three sides, you can really do all of this trig stuff. So if we're looking at the 25 degrees, I want to label the hypotenuse, the adjacent side, and the opposite side. I always, again, start with the hypotenuse first. Okay, so the side would be the hypotenuse. And then looking at the 25, which of these sides would be opposite of it? Again, I like to think of an arrow pointing to the opposite side, farthest away. And then the last side would be the adjacent side. Okay, well, I'm going to erase that side because there's nothing on the hypotenuse, so that's not going to do us any good. Okay, so I'm left with the opposite side and the adjacent side. Now I wrote our acronym back up here. So which of these ratios, sine, cosine, or tangent, uses the opposite side and the adjacent side? That would be tangent. Okay, and tangent of what angle were we looking at would be the 25 degrees. So we were using the 25-degree angle when I labeled the sides. And tangent is the opposite side over the adjacent side. Okay, so now I have an equation set up. Now if you remember that should just be a number. So if I type this in my calculator, tangent 25, that is just a number. So I know tangent of 25 equals like 0.47, okay? But I don't want to round it. These are irrational numbers. They go on forever, so you don't really want to round it. So I'm going to leave it as tangent 25 in my equation until the very end. But I want to get x by itself. So that means I want to get rid of the 18. Now this is x divided by 18. So I want to do the opposite of dividing. So I'm going to multiply by 18. So if we were in school still, I would make you guys, these would be the 3 steps you would always have to show. Now, those of you that don't like to show work are lucky, I guess, because you get out of that. But I would make you show the initial equation, and then this middle step where you're, getting x by itself, and then the answer. So this is kind of what you type in the calculator then. Now, these kind of go together, so it would be incorrect to move, like there always has to be an angle, the angle with the trig ratio you're using. So what you're going to type in the calculator is we're going to take 18 times that tangent 25. And now remember that was basically 0.47, but we're not going to round. So you're just going to say 18 times tangent of 25. And that's about, we're going to round to the 10th, the directions say, so that's about 8.4. Side is about 8.4. Okay. All right, now if you wanted to check your answer, if I take 8.4 divided by 18, I get about 0.47. So again, it's not exact because we had to round, so you don't get exactly what that number was, but close. Okay, next one. So again, I'm going to label my sides with respect to the angle I'm given. So this time I'm given the 70-degree angle. So I'm going to label my sides based off of the 70 degrees. So the first side I always do is the hypotenuse. And then the opposite side. And the adjacent side. Now I look at the sides and I'm going to ignore the side that doesn't have anything on it. So again, this side here didn't have any information. So I'm left with the hypotenuse and the adjacent side. Which of the trig ratios uses the hypotenuse and the adjacent side? That would be cosine. Okay, cosine of the 70-degree angle is the adjacent side over the hypotenuse. So this ratio looks a little different. I'm using a different trig function, and then also this is 15 over x. Over here was x over 18. I mean, different numbers, but the fact that the variable's in the denominator means I'm going to have to solve this one a little differently. Now again, remember that cosine of 70 is just going to be a number. Okay, and so 0.34. I'm trying to figure out what I need to put in for x to get approximately 0.34. What, 15 divided by what is going to give me approximately 0.34. So to solve this, first thing I'm going to do is we don't want the variable in the denominator. So to do that, I'm going to multiply both sides by x. Okay. And now remember, cosine of 70 is just a number, 0.34 approximately. So I want to get x by itself. I want to get rid of this cosine 70. I'm multiplying by that, so instead I'm going to divide opposite. Opposite of multiplying would be dividing by it. And remember, you need to keep these two things together. That 70 needs to stay with the cosine. So this now is what you would type in the calculator. 15 divided by cosine 70. Now back up here, I said it needs to be 15 divided by something that's going to give you about 0.34. Yeah. And so I get 43.9 because we want to round to the 10th. And again, if I take 15 divided by 43.9, I should get about 0.34. Okay, let's look at one more. Maybe two more. All right. Oh boy, blurry. Okay, so label your sides. This is the angle we're given, so we're going to base our sides off of that. And we don't have anything on the hypotenuse. I'm left with the opposite and adjacent, so that'd be tangent. Tangent of the angle equals x over 13. Opposite over adjacent. Okay, this is an easy one to solve then. And we're going to multiply then. So x equals 16.6. Okay. One more. Okay. 61 degrees. I'm going to stop labeling all the sides. I'm only going to label the two. But if you're struggling, it would be good to label all three of the sides still. Because, again, the adjacent side is the trickiest to find. But 24 is opposite. X is the hypotenuse. Remember, we're looking at that angle. So this one's sine. Okay, so again, x is in the denominator, so we want to get it out of the denominator. Okay, so this is my new equation. I want to get rid of the sine 61, so I'm going to divide. Okay, and this is what you would put in the calculator. 24 divided by sine 61. And that's your answer.